So the next component of the webinar is to understand and to provide a bit more detail on the capability available through the AI WeatherQuest Python package that's been developed. So the Python package is set up into 3 components. These include forecast submission, forecast visualization, as well as forecast self-evaluation. For the rest of the presentation, I'm going to go into detail of how each of these components work, including the code that's needed to interact with these individual Python modules. Just to highlight, to use these tools, you must be registered to the AI WeatherQuest, and this can be done via the AI WeatherQuest website. We have also included, as well as this webinar, we have detailed read the docs documentation, which we'll put a link in at the end of the webinar for you to access. However, I'd highlight that if you do get stuck or you have issues, please look at this documentation, however, as it provides examples of how best you can submit a forecast. And finally, I'm just going to briefly explain to install the AI WeatherQuest Python package. You can use pip, and I recommend looking at documentation of how to install Python 3 and pip before running this command line, which will enable you to download the latest version of the AI WeatherQuest Python package. Okay, so the step-by-step guide. If we focus first on forecast submission. So to submit a forecast to the AI WeatherQuest, you should have an array which contains your forecast of a shape that is 5 quintiles, 121 latitude and longitude points, and 240 longitude points. When you have this array, you just need 4 lines of code for you to submit your forecast to the AI WeatherQuest. The first line of code essentially imports the correct Python module from the AI WeatherQuest Python package. The second line, you essentially create an empty X-array data array where essentially you provide us with the variable name that you are forecasting, the forecast initialization date, the selected forecast window, your team name and your model name, as well as the password that you received in your registration email when you registered to the AI WeatherQuest. Following this, you'll have an empty data array, which is configured so that it works correctly with ECMWF systems. And all we require you to do is to populate the values of that empty data array with the values that you have in your forecast. Just to highlight, I will be showing you this very quickly in a Python environment. Finally, and the final step is to then, once you've populated this empty X array, you can then submit the forecast to the AI WeatherQuest. And this requires the same variables as you had when creating the empty data array, with the addition of this populated X array that you see here labeled forecast. So just to highlight once again, line 4, you have the forecast submission when you call the Python function that's labeled AI WeatherQuest forecast submission. You give it the forecast that you've populated along with the variables that enables us to understand what you are forecasting. And then once again, you give it the password that you have received during within the registration email. Just to highlight, when you run this forecast submission piece of code, several checks will be performed. So, for example, to ensure that everyone is submitting forecasts at the same time, we check that the initialization date is a Thursday, and then it also sits within days 1 to 4 of the forecast workflow. We also check that the coordinates have the correct shape and the correct values. So, for example, that your latitude values go from 90 degrees latitude to minus 90 degrees latitude. And what we also do is we check that when we sum the quintile probabilities, so when we sum across all of the probabilities across the quintile axis, that these equal to 1 with a very lenient plus or minus 0.2 either side. There are additional checks that are also going to take place, and I recommend you reading the Read the Docs documentation for you to understand these checks in a bit more detail. Additionally, when you submit a forecast, you can also visualize this forecast and see how it will appear on an ECMWF style portal. And to do this, you just need your 2 lines of code with the addition of the forecast that you've submitted to the AI WeatherQuest. So first, to do this, what you need to do is import the plotting forecast Python module. Similar to the forecast submission, you type out from AI web request package, import plotting forecast. And then I've just generated a simple function that will plot the forecast for a specified quintile number. So here what you do is you type in the Python function, you refer to the plot forecast function within that module, and then you give it the forecast that you have submitted to the AI web request, the quintile number that you want to plot, where in this case 1 refers to the first quintile, so probabilities below 20% of the climatology, 2 refers to between 20 and 40% of the climatology, etc. And finally, there's an option for you to give it a local destination on your computer where you plan to save the figure. However, this parameter is not necessary for the function to run itself. On the right here, you can see what this forecast looks like. So this is actually the 2-meter temperature probabilities of the highest quintile for the forecast that was initialized the first day just gone for week 3 of the forecast. So this is between the 19th and the 25th of May. You can see I've given it a team name of the ECMWF test and model name webinar test. And you can see here the probabilities of these extreme temperatures. And personally, I'm into research within the tropics, and we can see quite high probabilities of extreme temperatures across East Africa, as well as across the Indian continent. Just to highlight that this visualization code is only compatible with the arrays that are submitted to the AI web request. So please don't go ahead and try and input your own unique netcdf files. For example, we read what the team name and model name attributes are of the forecast that you submit. And just to highlight once again, the color maps, for example, that will appear on the screen when you use this function are similar to the forecasting portal that will be hosted at ECMWF during the competition phases of the AI web request. And then finally, just to highlight how forecast evaluation works. So during the AI web request testing period, you will be submitting forecasts, and we encourage you to use the code that we developed to work out the global ranked probability skill score that will also be used during the competition phases and displayed on the leaderboards, and will be how we compare individual contributions to the quest itself. So to perform your own forecast evaluation, what you essentially do is import the retrieve evaluation data and the forecast evaluation Python modules from the AI web request Python package. You then have 3 lines of code to import the appropriate data that is needed for you to perform your own forecast evaluation. So this includes the observations that occurred during week 3 and week 4 of the forecasted period. It includes the quintile climatology, so essentially where in the historical record do we see the 20th, 40th, 60th, 80th and 100th percentile, so that you can then fit the observations within the correct quintile bounds. And then finally, you can retrieve the land sea mask that is then used to essentially work out the skill scores over land points only. For each of these 3 imports of data that is used, you essentially need to give us the date, which for the AI web request will only work with a Monday start date, as well as the variable that you are planning to evaluate. So, for example, in a few weeks' time, you may choose to evaluate forecasts that were initialized on the 1st of May, so the previous Monday. So you would give us the respective week 3 start date, the variable. So in this case, let's say you wanted near surface temperatures, you would give us TAS, as well as the password that you've received in the registration email. You will then receive the observations or the quintile climatologies or the land sea mask. You'll be able to download this from the ECMWF system. And then finally, there are 2 lines of code that you need to run to work out the global ranked probability skill score. The first is this function called conditional obs probs, which essentially puts in the observations within the correct quintile boundary. And I've outputted this as obs PBS. So essentially observations probability, and then you use this observation probability, which is a matrix of where the observations sit within the quintile boundaries, to work out what the global ranked probability skill score is. So here you'll have your submitted forecast, you have your observations metric, as well as the variable and the land sea mask, and this will give you a single value which will show you what the ranked probability skill score is for the submitted forecast that you've inputted. Just to highlight, so the code that you can see on top is an example for the weekly ranked probability skill scores. So essentially the ability to compare one set of forecasts with one set of observations. However, in the read the docs documentation, there is an example of how to calculate the aggregated ranked probability skill scores, which will be used primarily to work out the winners of the competition. Okay, now we're going to do something very brave, is we're actually going to go live. So what I'm going to do is I'm going to show you under a Python environment how you can submit a forecast yourself, and hopefully you'll be able to see that it's quite a simple system. So what I've done here is I've run some initial code that essentially has downloaded the appropriate forecast data from ECMWF's dynamical model. So you should be able to see on the screen here, I have an array that essentially is storing the probabilities from the dynamical model from ECMWF for each of the quintiles of near surface temperature from a forecast run that was initialized on the 1st of May. If we have a look at the forecast shape, you can see here in the bottom right, I've just printed out the shape of that forecast array. Its shapes is 5, 121 and 240. And this corresponds to the individual quintile bounds, the number of latitude points, as well as the number of longitude points. So as Olga said in her slide, we're looking at a 1.5 degree resolution. So when you look at the number of latitude points this corresponds to, you have 121, and longitude points you have 240. Okay, so we have our array. It contains the forecasted probabilities. Now what I want to do is I want to submit a forecast to the AI weather quest. So what I do first is I import the forecast submission module of the AI weather quest Python package. The next stage is I want to open a empty data array. So with this forecast submission Python module that I've imported, I open up the AI weather quest create empty data array function, and I have 5 variables that I need to input. The first variable, the first parameter within the function is the forecasted variable. So in this example, I'm going to do near surface temperature. So we give it TAS. I'm then going to give it the forecast initialization date, which in this case is the 1st of May. The forecast window, so this is either a number that's 1 or 2, corresponding to week 3 or week 4. So in this case, I'm going to give it week 3 forecast, which is the first forecast window. I'm then going to give it the team name and model name. So in this case, I'm just doing a test. My team name is ECMWF test and my model name is webinar test. And finally, I'm going to give it that registered password that I received within the registration email itself, which here I'm calling password. I've already defined it. It will not be called password for you. So I then click enter with that function and you'll see several things that appear. So the first thing to appear is some checks that your model name and team name has been registered to the AI weather quest. Great, we can see here that ECMWF test has been registered, as well as webinar test has been registered to the AI weather quest. The next table you'll see is essentially what we've done is with your information that you provide from your team name and model name, we're essentially giving each forecast a unique identification. This is essentially to enable us to work with ECMWF systems in the future. So, for example, when we hope to put all the forecasts that we receive on Mars here at ECMWF, we need to give each forecast that we receive a unique identification. And you can see that the unique identification here on the screen. You'll also see, maybe you are included in this, that several of you have already tested the function and you have already received a unique ID that's associated with your team name and model name. I should highlight that as we give each forecast a unique identification, sorry, not as we give each forecast, as we give each combination of team name and model name a unique identification, the ranked probability skill scores across each competitive period and across the whole year will be based on this unique identification. So if you plan to submit and partake in the full year of the competition and would like to be awarded throughout the full year of the competition, please do not change the model name or team name associated with your submission. Once you change the model name associated with your submission, it will count as a new model, and therefore it will count as a different set of scores. So for example, if I wanted to partake and wanted an award at the end of the year, I would have to submit the same team name and same model name throughout the full competition for me to be eligible for an annual award at the end of the competition. Okay, so we have now created an empty data array, and I called it forecast. So when we print out this empty data array, you can see that it has the dimensions of quintile, latitude and longitude, 5, 121 and 240 longitude points, the same as what I plan to input. You will then see that with the array within this data array is essentially empty. So the values that you see are either very low or very, very close to 0. Then at the bottom, you'll see an array of coordinates as well as a list of attributes. These coordinates help us understand what you're forecasting, including the issue date, the period start date, and the period end date, as well as the attributes associated with that forecast. So for example, here we're forecasting the 2-meter temperature probabilities, and therefore we're giving this information within the X-array itself. You'll also see that you have your unique experiment number as well as the team name and model name within this X array. So now what I want to do is I want to populate the values of this array with the forecast data that we had at the start. I have made an error. I've not called that forecast values. So what you do here is you essentially call the values component of this empty data array and you assign it with the forecasted array that you had at the beginning. So here all I've done is I've said forecast.values equals the forecast data that I'm giving it. The next component of the submission is calling that submission component of the forecast submission module, where essentially you give it the forecast and the same variables as we described previously. When you enter that, you should once again see a check that you are registered to the AI request, both the model name and the team name. You'll see that there's a quick check of the coordinates are correct within the forecast that you're submitting, that all data is between 0 and 1. And then you should also see, once again, your experiment ID within the table of all submissions. And then finally, at the very end, you will see 3 lines of code. So the first line of code is essentially saying, we recognize your initialization date, and we're going to generate a folder here at ECMWF within the forecast submissions. You'll then see that it labels your forecast submission as a netcdf file, and it will essentially either say existing file has been deleted. So in other words, I've already submitted something to the AI web request and it's trying to re-upload it. So it deletes the old one and submits the new one, or you won't see this line. And in that case, it's just uploaded the latest version that you had. So 4 lines of code to submit a forecast. I know we are very quickly running out of time, so I'm just going to quickly show you how to visualize the forecast yourself. So what you can do is you can import the plotting module of the AI web request Python package, and then you have 1 line of code that you can run to plot the forecast itself. So here what I'm doing is I'm calling the plot forecast function within the plotting forecast module. I'm calling the forecast that I submitted to the AI web request. Just change that to forecast submit, and I'm calling the 5th quintile. So this is the quintile that's within 80 to 100%. When I enter that, you can see that it's not produced any output. What I can do is I can go to my working directory and I can display the latest forecast that is just being computed. If you give me 1 moment, So display, you can see on the screen here, essentially the forecast that I was showing you in the PowerPoint slides. So these are the 2 meter temperature probabilities for the forecast initialization date of the 1st of May for week 3. Once again, using the team name and model name attributes that are contained within the submitted forecast that you give. I'm not going to go into detail of how the forecast evaluation works. However, if you follow the slides or the read the docs documentation, you should be able to perform your own forecast evaluation using the code provided. So finally, just a few tips from me from a technical point of view. Please check that the inputted variables that you submit to the AI Weather Request Python packages match the same variables that you have given to the registration. So what you registered on the AI Weather Request website. I should also say, please update to the latest version of the AI Weather Request Python package. As of this morning, I've just released version 2 of the AI Weather Request Python package, and you can use the function on the screen to upgrade to the latest version. As I've said many times, there are detailed step-by-step guides of how to use the functions that we've developed in the Read the Docs. And finally, throughout the testing period itself, we've got 13 weeks to make sure that we have a working system. Please don't hesitate to get in touch, whether that's via the forum or email, if you have any issues, and we'll aim to respond to those queries as quick as possible.